Hey folks, well, we've gotten through the material on functions and input and output and variable scoping, local variables and global variables. And so now we want to get into decision making and control in a program. How does a program decide if it should do one thing or do something else based on whatever information or choices the user is making? So this is where we'll get into if and else statements at first, and then we'll get into a few other control structures after that. So let's see how we can go here. So the idea is nearly every program when it runs has to do some kind of decision making. You know, if it asks the user to enter a value and it's going to do some computation, once it reads the value in, it has to make sure that it's actually valid. If it gives the user a choice, do you want to do this or do you want to do that? Then it's got to read the choice the user makes, or if the user clicks on something to make their choice, it's got to detect which one they picked. And then if they picked one action, do one thing. If they picked a different action, do something else. So the program has to be able to make some kind of decisions. So we're going to start off with the most basic form of control structure in our language to make decisions. And it basically involves looking at one true-false condition, checking one thing, and if it's true, do one set of actions, otherwise do a different set of actions. Nearly every programming language has this. It's typically called an if statement, and then there's a variety of different options that can get tacked onto it that we'll take a look at. And then we'll take a look at Boolean logic systems, the idea of logic systems that work on true-false values. And they're going to kind of underpin a lot of the decision making that our programs make. But we'll get there just kind of one step at a time. So we will eventually introduce new variables to hold true-false values, but again, we'll get there in a little bit. So the most basic form of control is just two-way. If some condition is true, do one thing, else, otherwise do something else. So the syntax in C++ is to use the keyword if to basically say, okay, a decision-making point is coming up, and then the condition we want to check. So if I wanted to do one thing if x is smaller than y and something else if x isn't smaller than y, then I could throw in a test like this and say, okay, if x is smaller than y, here we're just going to print out whichever value is smaller. So here we'll say if x is less than y, and then in the curly brackets, we put whatever block of code we want to do in that case. So if x is actually less than y, here are the things we want to do. Now, in this case, I've just got the one cout statement, but we could have as much code as we wanted in there, just as long as all the different statements were separated by semicolons. So here, if x is less than y, I'm going to print out, x, whatever the value of x is smaller than, and whatever the value of y is. And then for the opposite case, if that's not true, if that condition isn't true, so if x is greater than or equal to y in this particular circumstance, we throw in an else block. So this is saying, essentially, otherwise, here are the things to do. And again, we put them in our curly brackets, and we can have as many statements as we want. Again, here I've just got the one that says, okay, well, whatever the value of y is smaller than, and whatever the value of x is. So the program will look at this condition and pick one of those two blocks of code to run. So it'll either do the first block or the second block, depending on whether the condition is true or not. And then once it's finished, so if it does the first case, it'll do that first cout statement and then jump to whatever is next in the program. If x is not less than y, then it will do the else case, whatever code is in there, and then go on to whatever the rest of the program happens to be. Now, it's possible that we've got a bunch of different cases we want to check. So it might be the case that I want to handle it differently if x is actually equal to y. So I want to know, okay, is x equal to y? If not, is it less than y? Otherwise, I've got other things to do. So we can throw in kind of extra layers to this check using what's called an else if. So I can say if x is equal to y, and just a weird little C syntax or C++ syntax issue here, if you want to compare two values to see if they're equal or not, you use two equal signs rather than one. Remember, we use the one equal sign when we want to assign a value from one variable to another. So two equal signs here is saying, okay, if x is equal to y, then do this first block of stuff. Otherwise, else if x is less than y, do this other block of stuff. And then a final else case here saying otherwise, if neither of those are true, then do this block of stuff. So this is either going to wind up, when this runs, it's either going to say x is equal to y, inserting the values for x and y, or it's going to say x is smaller than y, or it's going to say y is smaller than x. Again, inserting the right values for x and y. So we can have as many different layers of this as we liked. If I wanted to say, well, if x is equal to y, do this. Otherwise, if x is less than 0, do this. Otherwise, if x is less than y, do this. Otherwise, if x is greater than 217, do this. So you can have as many different conditions as you like. And these conditions, we'll look at how to create more complex and more interesting conditions to check in the next little while. And again, what's going to happen is when this block of code runs, right, it's going to evaluate these conditions and decide which one of these things it will execute. And it will execute that one block and then move on with whatever's after the whole statement here in the rest of the program. So again, it's always going to do one of these three things. Or if you've got a couple of else ifs, it'll do one of those four things and then move on with the rest of the code. So again, just quick example here. Let's get a program that asks the user to enter a number between 1 and 10. We'll read it in, and then we'll check, and we'll tell them if the value they entered was too small, too big, or a valid entry. Right? So we'll do our first printout statement saying, please enter a number between 1 and 10. We'll have a variable to read it into. We'll read the value they actually type in. Here we're not checking to see if they really entered a number. We're assuming that they did actually enter a number, but we'll get to error checking that soon. And then we'll say, okay, well, there's a couple of possible error cases here. They could have entered something that was too small, or they could have entered something that was too big, or they could have entered something that was valid. So we'll have those three different blocks. Right? My first test here is going to see if the x they entered was too small. So if it's less than 1, it's an error. So I'm going to give them some kind of meaningful error message. I'm going to tell them what value they entered and tell them that's too small and give them some kind of an idea of what it really should be. Right? So they entered a value that was too small, it was less than 1. If that's not the case, so if x is greater than or equal to 1, then we should test and see if it's too big. So otherwise, else if x is greater than 10, it's too big. So we'll tell them, whatever value you entered is too big, and give them an idea of what it should have been, right? The thing they entered was larger than 10, so that's the boundary. Give them an idea of what the boundaries are. And again, otherwise, so if neither of those two things are true, if it wasn't too small and it wasn't too big, then I sound like Goldilocks here, it must be just right. So we'll say, else, see out, okay, whatever the value is a valid entry. And if we had some kind of data processing, if we were actually using x for some purpose, then in this case, we would throw in the code that actually used it and as many statements as we needed. But this is going to be a pretty common habit we get into, is actually prompting the user for what we want, reading it in, and then doing some error checking to make sure that what they gave us actually is valid input. So pretty common format, and again, it's going to execute one of those three blocks of code. So a couple more examples. Let's look at functions to go off, and in these two cases, we're going to get the user to, or get a program that calls the function, passes it two values, and we want the function to return the smaller of the two. Now, in this case, you can't pass invalid data to a function. It won't compile. Invalid data types to a function. It won't compile. So inside the function, we know that we're actually getting, oops, I'm missing a closing curly bracket in there. Syntax error right about here. So we have our function. It's going to return an int that's going to be the smaller of the two. We'll call it min. It's taking two parameters, an integer parameter a and an integer parameter b. And we want to look at the two values, return the smaller. So we can say if a is less than b, what we want to return is the value in a. So I can just say return a. And then my else case would be, well, otherwise, we'll treat b as the smaller. And so in this case, if they're equal, it's just going to return b. So if they're equal, I guess they're both the minimum and they're both the maximum. So else return b. And again, I'm missing a closing curly bracket after the return b there. And then the max would be just the the same idea, it's just we're returning the other one. So if a is less than b, return b, so return the bigger one, and otherwise return a, because a is, greater than or equal to b. So again, pretty common format, right? If we wanted to go through and maybe just confirm that a little bit here, let's try a minmax.cpp. So we've been using cins and couts a whole bunch recently. Let's do some printfs. So C standard IO. And so we'll have our min function, and we'll do it with our prototypes here, int a and int b. And so this is going to return the smaller of a and b. And then we'll do a max, so return the larger of a and b. So an int max, int a, int b. We'll have a main routine where we ask the user to enter two integers. Please enter two integers. Let's have our two variables to store whatever they type in. So we'll use a scanf to get each of them. Scanf, we want %d since they're ints. We want the first one, to go into num1. And then we'll do the same thing for num2. And then let's have a couple of variables to hold the results of calling our function. So let's call them smaller and larger. So we'll have these four variables, two that have the original values, one that's got what we compute as the smallest, and one that we compute as the largest. So I'll say smaller is equal to, and we'll call min, and pass it num1 and num2. And then larger is the max, and we'll pass it num1 and num2. And then we'll print out of %d and %d. The smaller is %d, the larger is %d. Let's see, so we've got num1 and num2 going to those first ones, and smaller and larger going into those last values. So that should more or less cover our main routine. We just have to get our two functions written, and so we've got our int min taking a and b, and again we'll just have this say, let's see, what do I want? For my min, if a is less than b, we'll return a. Otherwise, else, I want to return b. And then I'm going to just do a cut and paste here. My max is going to be pretty much the same idea. It's just I'm going to say if a is less than b, I want to return the bigger one. So I'll return b, and otherwise I'll return a. So that should hopefully take care of things. And I want to compile the beast. And we'll put this in min-max, and let's turn on our various warning flags and see what I've done in the way of typos and syntax errors. Ooh. So far looks good. So we'll run it. Please enter two integers, let's say 10 and 20. And of 10 and 20, 10 is the smaller and the larger is 20. Right, so far so good. Let's try it one more time, and let's enter 5 and 5 just to see how we go. Of 5 and 5, the smaller is 5 and the larger is 5. So yeah, seems to be doing reasonably. Let's just experiment and try entering them in the other order and see if it still gets it right. So if I enter the bigger one first and the smaller one second, and of 20 and 10, smaller is 10, larger is 20. So yeah, looks good. All right. So we can go through and start using these if and else statements to go through and check conditions. Right here we'll try something a little bit larger, and I'll just kind of talk you through what's happening here. We're going to have a function that takes 3 parameters passed by reference and sorts them in increasing order. So you pass it any 3 numbers in parameters x, y, and z, and it'll go through and eventually put the smallest one in x, the largest one in z, and the one in the middle in y. So whatever values you pass, after the function runs, they'll be in sorted order. So inside, what I'm going to do is keep track of the smallest thing I've seen so far, the largest thing I've seen so far, and whatever the other value is. So I'm going to have 3 variables keeping track of the smallest so far, the largest so far, and the other value, the middle value. And I'm just going to look at x and y first. Right? If x is less than y, then I can say, okay, the smallest thing I've seen so far is x, and the largest I've seen is y, and otherwise just the other way around. The smallest thing I've seen so far is y, and the largest is x. So remembering the smallest thing I've seen so far. And then we'll take a look at z and figure out whether z belongs below the smallest, or in between the two of them, or above the largest. And so we'll just throw in a set of tests to say that. Say, okay, well, if z is less than the smallest thing, then z is going to be the smallest one. The thing that I had in small is actually going to be the middle one. And the thing I had as the largest is actually going to be the largest. So if z is less than small, then I'll store what I used to think was the smallest value in middle, and note that, okay, z is actually the smallest value. So in that case, I've got my ordering correct. But of course, z might not have been the smallest thing. It could have been the largest, or it could have been one of the middle value. So we'll have our next case. It says, okay, well, if that wasn't it, if z wasn't the smallest, let's see if it was the biggest. So if the biggest thing I'd seen so far was smaller than z, then z's going to be our new biggest value. And so we'll do the same sort of idea. We'll say, well, what I used to think was the biggest value is actually the middle one, so I'll assign that to middle. And z is actually the largest one. And the smallest was correct in the first place. It actually got the smallest value. And if that's not the case, if z isn't the smallest and it isn't the biggest, then it must belong in the middle, in which case the thing I thought was the smallest really was the smallest, and the thing I thought was the largest really was the largest, and so all I have to do is put z in that middle value. So now I've got the smallest, largest, and middle values remembered. I just have to remember to put them back in my parameters. And again, since this is passed by reference, it will actually change whatever variables were passed to it. So I can set copy small into x, middle into y, and large into z. And so again, we can start using these ifs and elses to think through logically what we want to happen and put together the right sequence of events. And quite often it does wind up doing things like this, where we remember kind of intermediate values that we computed and correct or adjust them as we go along. Now, sometimes we want to get more complex expressions put together. So we can chain different conditions together. If I want to say something like if this one condition is true and also this other condition is true too, then do something. Or if I want to make a statement along the lines of if this condition is true or this other condition is true, if either of them are true or both of them are true in that case, or there's also a possibility, then we'll use an or. So the symbols in C++ are the 2 ampersands to mean logical and the two vertical pipes, the 2 vertical bars for meaning logical or. And then there's also a not to take the opposite of something that we use the exclamation mark for. So if I want to see, for instance, let's say I have values x, y, and z. And if I want to see if essentially y is the middle value, I could say, well, y is the middle value if it's bigger than x and less than z. So I can put together an expression like this that says if x is less than y and y is also less than z, then y is my middle value. Or similarly, if I've got variables a, b, and c, and if I want to see if a is less than either one of the other two, then I can say if a is less than b, or if A is less than C, then do whatever actions are taken next. So we can start building up these compound expressions. And of course, the bigger and more complex the expressions get, the trickier it gets to write them correctly, to read them when you're trying to maintain the code, or to debug the code later on. But we can go through and build up these more complex expressions. And again, the other one I mentioned was the not. If I want to take the opposite of something. So if I want to say if it's not the case that A is less than B. So really that's just saying if A is greater than or equal to B. But if I want to throw a not in, it's just an exclamation mark in front of the condition that you want to check. Now, in general, I would recommend doing a reasonable job of parenthesizing these to make sure that it is taking the not of what you're actually expecting. So remember your brackets just for clarity. Now, there are a whole slew of different logic operators for comparisons. Right? We've looked at the less than. You can also check if something is greater than another value. You can check less than or equal to, so the less than comes first and then the equal. You can check the greater than or equal to, so again, the greater than symbol and then the equal. Comparing to see if two things are equal, so that uses the two equal signs. And checking to see if two things are not equal to each other, so the exclamation mark for not and the equal sign. So those are all ones that we'll use a fair bit this term. Now, it's not at all unusual to have, a handful of different specific data values we're interested in. I want to do something specific if x is 10. I want to do something else specific for the value 15. Cases that we want to handle specially for whatever reason in the program itself. So I could go through and then, maybe some general case for any other value. So here, for some reason, I'm assuming that 10, 15, and 17 are special values as far as this program is concerned. So if x is equal to 10, I want to do something. Otherwise, if x is equal to 15, I want to do something else. Otherwise, if it's 17, I want to do something else. And then if it's anything else, then I've got, some block of code to handle the kind of default case, if you like. So this is not at all unusual in terms of syntax. But again, if you've got a lot of these cases, it can get a little cumbersome to write them all out. So there's an alternate control statement available to us called a switch statement, where we say which variable we want to look at and which specific cases of data value we want to consider. So it will have the same effect when it runs as this kind of a layout, and either one is perfectly valid. It's just a different way of expressing our ideas. So it's called a switch statement, and so we say switch, and then we give it whichever variable or expression, whatever value it is we want to look at, and then we list each of the different cases we're interested in. So in this one we had a case for 10 was a special case, a case for 15, a case for 17. And so for each of them, we give the actual value and then the colon, an actual value and a colon. And so we list all of these cases, and then that final default case at the bottom to handle anything that wasn't specifically listed above. And again, when this runs, it'll go through and find the first case that matches that value, run that one case, and then jump to the end of the switch. Except, you'll notice I've got these break statements in here. So I can have as many lines of code as I want, as many statements as I want in an individual case. So I could have my case 10, and then I could have, 10 or 20 or 30 different lines of code here for whatever it's going to do in that case if x is actually equal to 10. But then I include this break statement to indicate, okay, here's the end of case 10. Similarly, however much code I had for case 15, at the end of it all, at the end of the final statement for case 15, I would throw in a break. And that's saying, okay, here's the end of case 15. And the break is essentially telling it to break out of the switch statement and go on with the rest of the program. If you happen to forget a break statement between two cases, then say the value actually was 15 in this particular example, it would jump to 15, do all of the code for 15, and then since you didn't have a break in there, it would go on and also run all of the code for 17. And then when it hit the break at the end of 17, it would jump out. So that is something to keep in mind. If you if you find your programs seem to be running all of the instructions for a whole bunch of cases, it's usually just missing break statements in there. Now, that might seem a little weird, but it allows us a way to take a bunch of specific data values and group them together and give the code for that specific value. So, for instance, let's suppose we're getting the user to enter a command, enter Q to quit, or C to continue, or enter, H for a help menu, or whatever the different options are. So we want them to enter a single character, we store it in a variable someplace, and then we want to look at that character and say, okay, well, if they chose H for help, do this. Otherwise, if they chose, Q for quit, do this. Otherwise, if they chose C for continue, do this. So we want to do a switch on whichever variable is holding that character. So let's assume we stored their command in a variable named, a char variable named command. And we want to have a whole bunch of cases. So for each of these cases, we list the specific character value we're interested in. So if they typed in lowercase q, give all the things they're supposed to do. Or if they entered uppercase q, give all the commands they're supposed to run. If they entered a lowercase h or an uppercase h. But where this omitting the break comes in handy is, suppose I don't really care whether they enter lowercase q or uppercase q. Either one is fine. If you enter lowercase q, it'll quit. If you enter uppercase q, it'll quit. But I don't want to cut and paste the exact same code for both of them. So what I do is list the two cases together. I have my case for lowercase q. I have my one for uppercase q with essentially nothing in between them. And then after the bottom one, I put all of the code for quitting in here, and then a break. So if they actually typed in a lowercase q, the switch comes down here and says, okay, it's this case, and it trundles on down. It doesn't see a break, so it keeps trundling down, looking for the code to actually run. And it runs our quit code. So we can start grouping values together. So again, this can be handy. If there's a couple of different data values where you want to run essentially the exact same code, this is a handy way to lay out our switch statements. Now, again, in things like the quizzes, I'll probably check to make sure that you can use switches and you can use else ifs. But in general, when you're writing labs or when you're writing your project, I'll just let you use whichever one seems the most intuitive, the most fitting for you for what you're trying to achieve. All right, the last thing I wanted to bring up here, and we'll make use of these a fair bit as we get deeper into the course, is the idea of a Boolean variable. So this is just a regular old variable. We're just creating a new data type, right? We have data types for chars to hold characters, for floats to hold floating point numbers, for ints to hold integers. Now we're going to have one that can store a true or a false. And essentially we're going to use this to remember, if I go through and do some complex series of checks, I'll use these Boolean variables as a place to remember whether I decided something was true or whether it was false, so that I can do my computations, and then sometime later on I can look at it and go, now did I say that was true or did I say that was false, and do a different action depending on that. So the data type that we're going to use is called bool, and it's short for Boolean. George Boole was the person who came up with the sort of Boolean logic system in the first place, so hence the name. But the data type is called bool, and we can actually assign values true or false. So actually using the word true or the word false, not in quotes or anything like that, just true, just false, and store those in variable values. So just as a quick example here, I'm going to say, let's suppose that the user entered some data, and I had some complex series of tests I wanted to do to determine if the data was valid or not. So I could do those tests, and later on, if I wanted to do the same tests again, I could just, instead of repeating them, remember whether the first set of tests decided whether it was true or false. So I'm going to have a Boolean variable here to remember whether some user input was okay or not. And so I'm going to create a variable called, is data okay, and whatever name you like. So for is data okay, I'm going to say, well, I'll store a true value here if the data was okay, and I'll store a false value here if there was something wrong with the data. So I declare it to be of type bool, and I say my is data okay? And what I'm going to do is just assume it was okay, and then I'll do some error checks, and if it wasn't okay, I'll change it to false. So I'll assign it a value of true initially. So again, we can just assign true to that variable since it's a Boolean variable. And then, somewhere down the road, I can read the data, the user input in, and I'll check and see if it's actually good or bad. So if we take the same sort of example as we were doing earlier and say it was supposed to be in some range, and if it's too small, it's bad, and if it's too large, it's bad. So here we'll say if the data is too small, if it's less than some minimum, then it's bad, or if it's too big, if it's greater than some maximum, then it's bad. And so in either of those cases, we'll just assign false to that variable. So now here, by this point, we've made up our mind whether that data is good or bad. And we can trundle happily on with whatever the program has to do. And somewhere down the road, if it wants to check and say, now, did I decide that data was okay or not? I can simply use the variable name, right? The variable's got a true or a false stored inside it. So I can say if and the variable name, and that's saying if that variable is true, right? If the contents of that variable is true, are true, then do one thing, else do something else. So this is actually perfectly valid, right? And it's going to, if the variable holds true, it will do this if statement, and if it's false, it won't do the if statement, it'll do the else. Right? So these are going to come in very handy, just for remembering things, remembering conditions that we checked earlier. All right, I will leave that there for now just to introduce the concept, and we'll start throwing it in different programs where we find useful places for it. Okay, I think that's where we will leave this one for now.